Okay, so here we have question 4, which is about centroids of volume of a composite body, and here we have a Dunkin' Donuts stadium seat. So we're going to be trying to determine the y-coordinate of center of gravity. So in order to do that, we're first going to start listing the shapes that we're going to use. So we're going to call this shape 1. We're going to call this vertical rectangular prism 2. We're going to call the filled semicircle 3. We're going to call the empty semicircle here 4. So now we're going to go in and start working on the problem. What I'm going to start doing is creating a chart with 1, 2, 3, and 4 for all of our shapes. And along with that, I'm going to list our y bar, which is it's the y-coordinate of the center of gravity for that shape. Along with that, I'm going to list v, which it stands for volume, the volume of the shapes. And lastly, I'm going to label y bar times v, because ultimately what we're going to do in order to get our y-coordinate of center of gravity for all of it is we are going to do sigma y bar v divided by sigma v, and that is what y bar will equal. So now I'm going to get started on this. So for this first one, the y bar is pretty simple. I actually look over here at that point 1, and I'm going to take it 1/2 of that because that'll be the y-coordinate of center of volume. So that becomes I do 0.1 divided by 2, which equals 0.05. So then I go on to shape 2, and it's a very similar process. I grab this 0.5 right here, and I'm going to do 0.5 divided by 2, which equals 0.25. I'm now going to go on to my shape 3. Now this is where it gets a little more complicated. In order to find y bar of a semicircle, what I do is I do 4r divided by 3 pi. Now r for this one, for shape number 3, is actually we're going to go and grab this, and we're going to divide that by 2. So we know here that if we were to take this shape here and grab the r from here to here, it's actually going to be that 0.5 divided by 2, which is the same as 0.25. So given that, we're going to now plug in 4 times 0.25, which gives us 1, and we divide that by 3 pi. When we do that, we end up getting about 0.611. 0.611 is what we end up getting for that. Now we're going to do the same thing for shape number 4. So we're going to go 4r divided by 3 pi. Now when I do this, I can just straight up grab my r value that I have right there of 0.125. And when I plug that in, I'm going to get 0.553. Now, I forgot to mention this earlier, but part of the reason why this is actually here is going to be 0.611, despite when I do 4, because that is not my straight value. What I have to do is I have to take the height here, this height I have right here, and I have to add it to what my y centroid would be for this, because shape 3 is on top of that other sheet. It's not resting on the y-axis, so that means I have to add the elevation that it already has where it starts. So that's why that's 6.11, because it's actually 0.5 plus 0.111, which then that's what gives me that 0.611. And it's the same thing for shape 4, where it's actually 0.553 equals 0.5 plus 0.053. So that's how I get those two values. Now I'm just going to erase that real quick so we can keep up the space. All right, so now moving on, we're going to go into volume. So the volume of a rectangular prism, as you know, is length times width times height. So if I do 0.4 times 0.1 times 0.5, I end up getting 0.02. So along with that, if I then do my I do the same thing for my vertical one, where I do that 0.5 times 0.05 times 0.5 as well, because this still applies to the same, this here is the same width. Those two are the same width, shape 1 and 2. So I do that again, and when I do that, I get 0.0125, if that makes sense. So then what I'm going to do is I'm going to calculate volume for my semicircles. And if you don't know, the volume of a circle is pi r squared times height. However, we're using a semicircle, so we're going to do pi r squared divided by 2, which if I plug into my calculator, I'm going to get 0.0049. So then that moves on to shape 4, where we're going to do a very similar thing as what we did to shape 3. However, this time it's going to be negative because it's a hole, because it's not actually existing there. It's a hole, like you could see through it. So therefore, it's the absence of volume in that area. So that means whatever I'm going to do the same thing, except I'm going to make it negative. So when I plug all my values in, I get negative 0.0012. So now if I was to take the total of my volume and add it all up, I'm going to do the 0.02 plus 0.0125 plus 0.0049 and so on. And I'm going to get approximately 0.0362. So then that moves, now I'm going to move on to my y bar times my volume column. So going through this, I'm going to take my y value here and multiply it by my v value. So when I do that, I'm going to get 0.001. Here I'm for shape 2, I'm going to get 0.003125. When I do it for shape 3, I'm going to get 0.002994. So then that moves on to shape 4, which if you keep in mind, my volume is negative, so that means my y bar times my v will also be a negative value. This, when I do that, gets me negative 0.0006787. So I'm now going to total all these up and add them together, and that will give me approximately 0.00644. Now what I'm going to do is I'm going to plug these two values in to my my equation, sorry, which then will give me this equals 0.00644 divided by 0.0362. Now when I do this out, I'm actually going to use the actual values that I have in my calculator, not these approximations. And when I do that, I end up getting 0.178 meters. And that is my centroid of gravity in the y direction. So that would mean that y bar equals 0.178 meters. Thank you.